All right, guys, I'm going to do the lesson on 6.2, and I'm going to do both sections. That way we can revert back to either lesson if need be. Okay, so 6.2, day one, which I am doing on Friday, November 17th, is going to be this page about the multiplying. But I'm going to go ahead and do the division on the back as well in this one video. Okay, multiplying. Let's first start with what we learned yesterday. I squared is equivalent to -1. So that is, first of all, extremely important for this entire lesson. Multiplying is really just what we already know from Algebra 1. When we have a number outside, remember we think of I just as a variable, we are going to distribute. So I'm going to write this a little bigger here. Okay, now I have room to show my distributive moves here. 5i times -2 is going to be -10i. Remember that I is just like an x. 5x times -2 is -10x. Now I distribute 5i times I. That would be 5i squared. Okay, here's the change of Unit 6 compared to what we already know from Algebra 1. I squared is equal to -1. So if we replace or substitute that, I squared is equal to -1. You multiply them together and get -5. And we want it in standard form. Standard form looks like this. The I basically needs to be in the back or on the right side of the expression. So this will be my whole number, 5 times -1. And then I just have -10i. So now it's in proper standard form as well. Okay, and that's all there is to it. That is the answer. Standard form here. Okay, standard form. All right, one more here. So now we have a binomial times a binomial. We can do the box method or FOIL. I will do the 2x2 box. We have 7 minus 4i, -1, positive 2i. Okay, now we're just going to do the box method. 7 times -1. Negative times a negative is going to be positive 4i. 7 times 2i, 14i. And a -4 times 2 is -8. And I times I is I squared. So there's another one of those I squareds where we substitute that -1 in there. So that's like -8 times -1. So our answer here is -7. These two are like terms. We can combine to make 18i. And now, instead of -8i squared, we have -8 times -1, which is positive 8. That creates two like terms, and -7 plus 8 is 1. Then we have that 18i, and it is in the standard form. Real number first, then the imaginary number. So that is pretty much multiplication. Then we move on to a thing called sum of squares. Remember the difference of squares pattern from just this previous unit a few days ago when we had something that looked like this. That's a shortcut, right? The square root of x squared, the square root of 16, and it is a difference of two squares. Well, we knew that shortcut was two groups with the front term in the front, one with a plus, one with a minus, and the back number in the back. And that was the answer. So today we're seeing a sum of squares. And it says now try using your knowledge to factor that. So a lot of times when I ask students what do they think that would look like, these are usually the two common predictions I get. X plus 4 and x plus 4. And then they'll say, if that doesn't work, x minus 4, and x minus 4. Well, the problem with both of these is because of the signs being the same, we're going to have that middle term. So for example, if I just did FOIL here, x squared, x times 4, 4 times x, 4 times 4. So there's that plus 16, but these two don't cancel. We have x squared plus 8x plus 16. So that does not equal that, of course. And this would be similar. This would be x squared minus 4x minus 4x. So you can already see, again, we're getting that x squared plus 16, but these two do not cancel. They give us that middle term, and this is a trinomial instead of a binomial. So why do we have this in here? Because now that we have knowledge of the imaginary numbers, we can actually have this, but we throw in an I, so it's the same pattern, one with a plus, one with a minus, but now we throw that I in after the 4s. So does this work? Well, let's look. If I FOIL here, x squared, this will look kind of weird. X times negative 4i would be negative 4ix. 4i times x, positive 4ix. And now in the back, positive times negative is negative 16. I times I squared. So look what happens in the middle. These two are opposites, so they cancel, leaving us x squared minus 16i squared. And here we go. We have that I squared, which is equal to negative 1. That changes that to a positive. Negative 16 times negative 1 is plus 16. So there is that sum of squares. Now we're able to perform those. And this is really easy because if you remember your difference of squares pattern, it's going to be the same, just with an I after each of the last terms. So let's look at two of those. 9x squared plus 1. So the square root of that is 3x. The square root of 1 is, of course, 1. So we do, in fact, have a sum of two squares. So knowing our knowledge from over here, let's put our two groups. The front term in the front, one with a plus, one with a minus, and the only change today is putting an I after the last term. So you have one I and one I, so you could just have an I, you don't need the 1 there. And that is it. So very simple and straightforward. One more, square root of x squared, square root of 81. So we have a sum of two squares again. Same pattern. Two groupings, front number, one with a plus, one with a minus, and now you just throw an I behind that. 9i, 9i. Short and quick there. Okay, let's move on to 6.2b. That is the backside here. Okay, this is just a recap here. Standard form for a complex number is a plus bi. So here we are talking about that word conjugate again, which we've seen in the past. So a plus bi and then a minus bi would be our complex conjugates. So basically that sign in the middle changes. We've seen that in a prior unit when we were dividing by radicals. Remember, we had to multiply by the conjugate. That is exactly what we're doing today. The product of complex conjugates is always a real number. So it's that same process where we cannot have an I in the denominator. We could not have a square root in the denominator. When two complex numbers are being divided, we will multiply by the conjugate of that denominator, and then we want to write it also in standard form. Okay, so kind of same knowledge here. We want to know That is going to be important. I squared is equal to negative 1. All right, let's try this first one. Now the conjugate of this, I'm just going to change to 2i because it's like 0 minus 2i. So I would just multiply times a positive 2i. But whatever you multiply on the bottom, you have to multiply on the top. Okay, so I'm going to put that in parentheses. That means we're going to have to distribute. It's on the right side instead of on the left, so just make sure you distribute into both here. 2i times 5 is 10i. And now the back. 2 times 3 is 6. And what do we have? I times I squared. We'll come back to that in a second. Now the denominator. Well, this is pretty easy. Negative 2 times 2, negative 4, I times I squared. Now, do not cancel these I squareds. It would have to be in all three. And if I cancel one I out of each of these, then I'm just back where I started. I have an I on the bottom. So we just want to look at all of our I squareds, which we have one here, and we have one there. Remember, that is equal to negative 1. So we would have 10i plus 6 times negative 1. This will be a step you can skip once you get used to that I squared being negative 1. I just substituted my I squareds for negative 1s. Okay, so now just multiply. 10i, 6 times negative 1, negative 4 times negative 1, positive 4. And I will want to get this in standard form. Well, actually, it's right there, it's the same thing. But first, all three of these could be simplified. We can divide by 2, giving me 5i minus 3. 4 divided by 2 is 2. Okay, so now let's put it in proper standard form. The real number needs to be listed first. So we have negative 3, positive 5i over 2. Okay, and that is the answer. Now, I'm not sure what it looks like in the Edulastic at this moment. Just know this means the same thing if I give them each their own denominator. So I'm splitting this fraction. It would look like negative 3 over 2 plus 5i over 2. So both of those are acceptable. On the test, it would not matter to me which look you prefer. Okay, we have one more here. Now we're going to have to do the full conjugate. We have a binomial on the bottom. So the only sign we're changing, remember, is that 1 in the middle. I'm not going to change that sign. So I will multiply negative 1 minus 4i. And that, again, would be top and bottom. And we are multiplying. It's coming a little bit out of focus. That's a lot out of focus. Okay. Now we're going to have to do box method twice, if that is your method, or you can do FOIL twice. I'm going to do the box. So I'll create my first 2x2 box. We have 3 plus 11i times negative 1 minus 4i. Now the bottom should simplify down to like one number, but the top might be a little more complex. 3 times negative 1, 11i times negative 1, that's just going to change the sign. 3 times negative 4i, negative 12i. Negative 4 times 11 is negative 44, and then we have those two i's, I squared. So there is that I squared. And I'm just going to put a little note here so I remember. This is my numerator, so the top. Okay, and we can probably go ahead and put that up here. These two are like terms. Negative 3. Those two combine. They don't cancel or anything. They're both negative. So a negative 23i. And then remember that I squared is a negative 1, and we have a negative 44. So that turns that negative 44 into a positive 44. There's the top temporarily. Yes, I see these two are like terms. So let's move on to the second box, the denominator. This is the denominator. All right, so the denominator is negative 1 plus 4i, negative 1 minus 4i. So here's where we need to have things cancel. That's why they're opposites. The numerator doesn't matter. The denominator, we need to remove all the i's. Remember down here, that last problem, we ended with no i's in the denominator. Negative 1 times negative 1. Negative 1 times negative 4i is positive 4i. Negative 1 times 4i is negative 4i. So there you see they're opposites. They're going to cancel. Negative times positive is negative 16. There is that I squared. So that I squared is a negative 1. Negative 16 times negative 1. The shortcut is it's going to change the sign. So this is going to end up being positive 16 plus 1. So we can show that here. 1 plus 16. Okay, now we're just going to simplify. And 44 minus 3, or negative 3 plus 44, is 41. Then we have minus 23i all over 1 plus 16, 17. And there is no common factor between these three numbers, so I don't need to simplify it. And there is the complex answer to that division problem. Okay, that is 6.2, day 1 and 2.